Okay. So basically what is going to happen, I'm going to be out of town, and the only 2 days affected will be this Wednesday coming up. So tomorrow and then next Wednesday. Okay. Those are going to be 2 days that will be affected by my leaving. So what's going to happen is there's going to be no Zoom tomorrow. There's going to be no Zoom next Wednesday. Again, no Zoom tomorrow, no Zoom next Wednesday. February 10th and February 17th. Instead, what we're going to have is we're going to be online. I'm going to have a video. Okay. I'm going to like this class basically is going to be the video. And if you need to rewatch this because because we're going to go through a lot today, or if you need if people that are not here need to watch this, then they'll watch this. And then also same thing for next Wednesday. Tuesday will be a repetition from Wednesday, so people will just watch the video and take notes and things like that on that. Okay. So those 2 days there will be no Zoom classes. You don't have to sign in. You just have to watch the videos and then do the problems that we do on the video. Okay. So Zoom links are there. Notes. These are going to be the notes we're going through. We're moving pretty quickly. We're doing about 10 slides per day. It's going to take us about 5 days to get through the slides. This diagram, okay, this is a stoichiometry mole island. You either have to print this or you have to make a copy of it. Again, you either have to print this or you have to make a copy of it. Either or is fine with me. If you can print it, great. If you can't print it because you're not at school and you need to, you don't have a printer, then obviously go ahead and make it yourself. I made this myself. It's pretty doable. It is doable. You don't need to be an artist or anything. You just need everything to be labeled correctly. Okay. And we're going to be using that a lot today. Worksheets that for practice purposes are this one. This is the one that I'm going to go through with the notes. This is going to be an extra practice worksheet just in case you need it. Okay, and answer keys. First answer key, second answer key. Okay, newsletter. Just understand molecular mass information in a balanced equation. You're going to learn how to use the balanced equation to determine the relationship between the moles of the reactants, the moles of the products. That's kind of what we did yesterday. We're going to learn to relate the masses of the reactants and the products in a chemical reactions, and we're going to understand what the term limiting reactants means. We're going to use the limiting reactant to solve stoichiometric calculations, and then we're going to learn how to calculate actual yield and using percentage of theoretical yield. Nobody from this class has element of the week. Green group Luis, if you're watching this, you're going to be watching this tomorrow. You have element of the week. You have praseodymium number 59. Okay. Joan, I'll see him today. But tomorrow, Jacob, make sure you turn in your, I'll send you an email too. Make sure you turn your element of the week. Once I have yours, I have Edlin's already. I should get Joanne's today, and then I should get Jacob's tomorrow. And then all of these 3 people will have grades for that. Okay. All right, let's get started on the lecture. So the first thing that I said I was going to do is I want to go through the worksheet through the problem that we did yesterday. Okay, I want to go through this problem that we did yesterday. We did number 1 yesterday. If you remember, we did number 1. I'm going to redo it right now with you, so please pay attention. It says, how many moles of HCl would react with 7 moles of zinc? So how many moles of HCl, this is where we're going to finish, would react with 7 moles of zinc? This is where we're going to start. Okay, we're going to start with 7 moles of zinc. We're going to end with moles of HCl. So we're going to write what we start with, 7 moles of zinc. Okay, and since we're going from moles to moles, okay, going from moles to moles, meaning we're using this, when we use this, we're going from here to here. It says you're going to use coefficients from balanced chemical equation. So basically, when you go from moles to moles, both the top and the bottom will be mole and mole. The only difference will be the following. Whatever you start with goes at the bottom. Again, if you remember, I said what you start with and then what you want to finish with. When you're going from mole to mole, the only difference here is the molecule. What you want to start with goes at what you start with goes at the bottom. So moles of zinc here would be at the bottom. What we ended with, which is a mole, what we have to finish with, which is moles of HCl, would be at the top. What you start with, what you end with. Now, what numbers go here? So depending on what molecule we have, here we have HCl. So we have to look for HCl in the formula, and we have a 2 here. So a 2 would go there. Moles of zinc. We have a 1 here. So a 1 would go there. We would get rid of moles of zinc. We would get rid of moles of zinc, and we have moles of HCl. So we would multiply by the top, divide by the bottom. 7 times 2 is 14. 14 divided by 1 is 14. So we have 14 moles of HCl. Okay. Questions? Okay, so let's go to the lecture. Oops. Come on. I wanted to erase this. Sorry. I want to erase this for next class. Let's go on to the lecture. Okay, now that's what we worked on yesterday. What are we going to work on today? So we did this one yesterday as well. So we're going to work with some more stoichiometry problems, and know that stoichiometry is kind of the process of using balanced chemical equations and information about that balanced chemical equations to solve for a certain compound. So basically, I'm going to give you information about one compound. You find out the information that's missing of the other compound. And you're going to use, like I said, the mole island sheet, and you're going to use a calculator. Okay, so now we are moving into the two-step problems. Okay, so the problem that we just did was mole to mole is just those one-step problems. But now we're moving from moles to mass. Now before, moles to mass was a one-step problem. However, now it will be a two-step problem because now we have a different reference sheet. And I'll explain in just a second. It says, how many grams of AgCl, so this is where we finish, how many grams of AgCl will be precipitated if 0.45 moles of AgNO3, this is where we start, is reacted with as follows. 2 AgNO3 plus CaCl2 gives us 2 AgCl plus CaNO3 2. Okay, so first, we're going to write what we start with. 0.45 moles of AgNO3. Now, I'm going to pull out my reference sheet, the reference sheet that we've been using. Okay, so we are starting in moles. Now, which mole is a good question. Which mole do we start with? Do we start with the one on the left, or do we start with the one on the right? Do we start with the one on the left, or do we start with the one on the right? The answer is simple. We always start to the left. When you read, right? When you read a book, you read from left to right, correct? Normally a book, a reading, a paragraph, whatever you have in front of you, you read from left to right. Same thing here. You're always moving from left to right. Never, ever, 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 ever are you moving from right to left. Again, you're always moving from left to right. Never, ever, ever are you moving from right to left. Okay? So, you are going to start where it says known A. You're going to start there. Where are you moving? Again, you can't move left. You can only move right. So you're moving from mole to mole. Here to here first. Again, you are moving from here to here first. Then, we're moving from mole to mass. We're moving from mole to mass. Why are we moving from mole to mass? Because the final answer needs to be in grams. It says how many grams of AgCl. So we need to move to mass. We cannot move from mole to from this to this. Why? Because that would be moving from right to left. We have to move from left to right. So first, we're going to move from mole to mole, meaning when we do this, we are moving from mole to mole. Remember, when you're moving from mole to mole, it's going to be mole, mole, but the compound is the one that changes. Again, the compound, the molecule is the one that changes. What you start with goes at the bottom. The compound that you start with goes at the bottom, meaning AgNO3 goes at the bottom because that's the compound we started with. The compound we want in our final answer goes at the top, meaning AgCl would go at the top. Again, the compound we start with goes at the bottom, just like the previous example. The compound we want to end with goes at the top when we do mole to mole. Now, number-wise, it says here, use the coefficients from the balanced chemical equation, meaning I'm going to look for AgNO3. AgNO3 has a 2. I'm going to look for AgCl. AgCl has a 2. You see that? AgCl, AgNO3. This way I can get rid of moles of AgNO3, moles of AgNO3. And now I have moved from here to here. And now I can move from moles to mass. I can move up from moles to mass. And I will use molar mass of AgCl over 1 mole of AgCl. Compound does not change now. The compound stays the same now. The compound stays the same now. Okay? So, we're going to do molar mass of AgCl over 1 mole of AgCl. Molar mass is the mass from the periodic table, meaning I need to look up Ag and Cl. Ag is silver, which is 107.87. Cl is 35.45. I believe this is 143 something. I just need to make sure this is 12. 9 plus 4 is 13. Carry the 1. 7 plus 1 is 8. 8 plus 5 is 13. 1 plus 3 is 4. And then 143.32. So we have 143.32 grams of AgCl. And this way I can get rid of moles of AgCl. I would multiply by the top, divide by the bottom, multiply by the top again, divide by the bottom again. So oops. Oh my God. Okay. Okay. So when I do this, it would be 0.45 times 2 divided by 2 times 143.32 divided by 1. I get 64.49 grams of AgCl. Okay. Let's do another one like this. This is from the worksheet, by the way. A problem like this is number 3. If 3.6 moles of zinc react, how many grams of hydrochloric acid are needed? Hydrochloric acid, by the way, is HCl. I will always give you the actual molecule. I'll never just put it in word name. This is a worksheet, but in quiz-wise, I will always tell you the molecule itself, the formula, not the name. Okay. So we will start with 3.6 moles of zinc. We want to finish with grams. So we start with zinc with moles, and we want to finish in grams, meaning we're always going to start with the left mole and move up to the right mass. Because we read from left to right, we move from left to right. So we're moving from mole to mole first. So both top and bottom would be moles. The unit that I start with goes at the bottom, which is zinc. The unit I want to end with goes at the top, which is HCl. And before I move on, I need to remember, use the coefficients from the balanced equation. Well, which is the equation? The equation's right here. So I'm going to use HCl, which is a 2. Zinc doesn't have one, so it's going to be a 1. Get rid of moles, get rid of moles. Now that I'm in moles, I can move up to mass. Now that I'm in moles, I can move up to mass. It would be molar mass of HCl over 1 mole of HCl. And again, the molar mass is what I calculate from the periodic table. So I have to look for H. H is 1.01. Cl is 35.45. If I add those together, I get 36.46. Okay. So multiply by the top, divide by the bottom, multiply by the top, divide by the bottom. That would be the following. So let's look at the calculator. We would have 3.6 times 2 divided by 1 times 36.46 divide by 1, 262.51. And that would be grams. Oh, by the way, sorry, grams of HCl. Any questions?
You said that we were gonna be able to look back on this video, right?
Yeah, it's recording.
Okay, perfect. Thank you.
So yeah, so tomorrow what I would suggest is maybe pause the video at certain points like before I do this problem, pause it, do it yourself, and then see if you got the right answer. For sure, that's what I would do tomorrow. Okay. We're gonna do one more that's a 3-step problem now. I'm gonna tell you right now. I'm gonna do a lot of 3-step problems on Friday, probably do them on Tuesday as well, before we even move on to any limiting reactants, which is kind of the next section in this chapter. Okay, I'm not gonna move on to complex things until we get the basics done. Okay. Now, this right here is a 3-step problem. And I'm going to show you why. For the following balanced equation, how many grams of chromium 3 oxide can be produced from 15 grams of solid chromium? So how many grams of chromium 3 oxide? Chromium 3 oxide is Cr2O3. This is where we finish. We're going to start with 15 grams of solid chromium. Solid chromium is just Cr. This is where we start. So in this problem, we are moving from a mass of chromium to a mass of chromium 3 oxide. Again, we are moving from a mass of chromium to a mass of chromium 3 oxide. So if we look at our sheet, we are moving from mass to mass. We are moving from mass to mass. We are moving from here to moles. Then we're going to do the mole to mole that we've done before, and then we're going to do moles to mass. Again, we're going to do mass to mole to mole, mole to mass. It's a 3-step problem. This is as complex as they're going to get. But again, like I said, we are going to do various examples before I say quiz or anything like that. So don't freak out. So what we're looking at, sorry. I meant to go back to my PowerPoint. Okay, where's my PowerPoint? Okay, I meant to be here. First, we're going to write what we start with. Remember, this is what we start with. This is what we finish. Okay, we're going to start with 15 grams of solid chromium, meaning 15 grams of Cr. So, using this sheet, basically we start on the left mass and we're moving downwards to the mole. We're starting in the left mass and we're moving downwards to the mole. So we're going from 1 mole over molar mass. So 1 mole of Cr to the molar mass of Cr. Why does it keep CR? How come we don't change to CR203? How come we don't change to another? Because we only change molecules. Again, make sure you know this. We only change the molecule when we go from mole to mole. That's the only time we can change the molecule. When we go from mole to mole. Right now we're going from mass to mole, so we're keeping the same molecule. The molar mass, as it says here, is from the periodic table. So you have to look for CR. CR is number 24, and it's 52 grams. So we're going to delete that, and we're going to write 52 grams. And this way we can get rid of grams of CR, can get rid of grams of CR. Now we are here. And now I can do mole to mole. Meaning top is going to be mole, bottom is going to be mole. So they're both mole. Now we change the molecule. First, remember at the bottom is always the molecule that you want to get rid of. At the bottom is the molecule that you want to get rid of. We want to get rid of CR. I don't like how I wrote CR there. We want to get rid of CR. What do we want at the end? We want chromium 3 oxide, or we want CR2O3. We're going to use the coefficients from the equation. CR2O3 has a coefficient of 2, so we have a coefficient of 2 at the top. CR has a coefficient of 4, so we have a coefficient of 4 at the bottom. And that's how you go from mole to mole. And finally, we go from mole to mass, meaning we go up. So we would go from molar mass over 1 mole. Molar mass of CR2O3 over 1 mole of CR2O3. Okay, this is from the previous one. So now it's going to be CR2O3. CR2 is 52, but now we're going to multiply it by 2. O is 16. 16 is times 3. 52 times 2 is 104. 16 times 3 is 48. 104 plus 48 is 152 grams. So the molar mass here, is 152 grams of CR2O3. So moles of CR get rid of moles of CR2O3, moles of CR2O3. And for this one, it's always multiply by the top, divide by the bottom. Multiply by the top again, divide by the bottom again. Lastly, multiply by the top, divide by the bottom again. So, where is my calculator? There it is. Oh, come on. Why do you do this? Sorry, guys. Let me see. Hate that it does this, and I'm not hopefully. Oh, okay. There we go. Okay. There we go. Okay. 15 times 1 divided by 52 times 2 divided by 4 times 152 divided by 1. We get 21.9230, so on and so forth. So final answer would be 21.92 grams of Cr2O3. Okay. So the next slides are just kind of the steps on it and how you would do it. And they got the same answer. So the bottom, the conversion string is kind of the bottom basically that we did. And how we got our answer. Now, this is what I want you guys to do. So basically, I mean, I would say homework / practice purposes, I want you guys to try this. Now, I know the PowerPoint gives the answer. I know that. But obviously try it without looking at the answer first and using just kind of tactics from the previous problem. So what I have done from the previous class, and I forgot to do it right now, and I'm going to do it after this period, is I have taken screenshots of my work for every single problem that we did today. I have taken screenshots. What I'm going to do is I'm going to post them and upload them and change the names as in conversion between moles to mass, conversion between mass to mass, conversion between moles to moles. So you guys kind of have like an example. Okay. And obviously you guys have this video. So what I would do is before you try to solve this tonight, if you don't remember, try to watch the video. This is another mass to mass. It says how many grams of tin 2 fluoride can be produced from 55 grams of hydrogen fluoride. Tin 2 fluoride is this one right here, SnF2. Hydrogen fluoride is, I just don't want to, hydrogen fluoride is this one, HF. Okay, so again, tin 2 fluoride is the SnF2, hydrogen fluoride is the HF. Okay, so again, try to solve this, see how it goes. If you can set it up and get the right answer, that's awesome. If you can't do that yet, that's fine. Friday, we'll do this again. We'll do a lot of examples Friday to make sure that before I let you go and I'm like, here, you know, you're comfortable with this. Okay. Any questions? All right, guys. So that's kind of the end for the lecture. So what I'm gonna do is obviously I'm gonna post this lecture on Google Classrooms. I have to upload it on my YouTube channel first, and then from my YouTube channel, we'll put it here because I know with YouTube you guys can access it that way in your phones at anywhere, basic tablet, computer. You don't have to have, it doesn't just have to be on the computer. So that's why I like using YouTube. So you have a link there, and you guys can pause it, you know, pause the watch and then keep watching it later. Okay. All right, guys. So I will see you guys tomorrow. Try that problem, please. Okay. Try it. See how it goes. Okay. All right, guys. Have a great day.